Okay, so today we're talking about the angle addition postulate, and basically this is sort of like the supplement to the segment of addition postulate that we talked about before. The same sort of thing that applied to the segment addition postulate is the same sort of thing you're going to expect from the angle addition postulate. So let's look at this angle here. I've got this drawing here of this really big angle RST, okay? And then I have a line coming out here with point P there, and it breaks it up into these two smaller angles, measure of angle RSP and PST. Note the way I have this written here with a little m in front of that stands for the measure of. So the way you would read this little angle is the measure of angle RSP, the measure of angle PST. So a little m in front of the angle, that's just sort of a standard notation in geometry. It's something you should know. All right, so if I have that sort of situation here where a big angle is being cut into two smaller angles, then the obvious is stated over here on the right. If P is between or in the interior of RST, so here's RST and P is between those two, between that angle, then this statement is true. The measure of RST, the measure of the big angle, is equal to the sum of the two smaller angles. A measure of RSP plus the measure of PST. Okay, so that's the angle addition postulate in its most basic form. Basically, it just says that if you have a big angle being split into two smaller angles, then the sum of those two small angles is equal to the big angle. And what that's going to allow us to do is define the measure of certain angles based off of what we know about some of the angles. Okay, so that's the angle addition postulate. Now let's look at a couple of examples. All right, so what I've got here, and I hope you can read it well, I say that measure the angle LKN, so this big angle here, that's equal to 145 degrees. And then I've got these two smaller angles where this is 2x plus 10, this small angle is equal to 2x plus 10, and then this other small angle here is equal to 4x minus 3. They want us to find the angle LKM and angle MKN. So they give us x's and stuff here. We need to find x first, and then when we find x, we'll plug the number in to these values here and see what the actual angle is. So stating the angle addition postulate, we can say that angle LKN, the big one, is equal to angle LKM plus angle MKN. Okay, so now all we're going to do is take and substitute the values that we know. They give us in the problem angle LKN is equal to 145, so let's replace that with 145. They tell us in the problem that the angle LKM, this angle right here, is equal to 2x plus 10. So that's 2x plus 10. And then angle MKN here is equal to, that's going to be plus, angle MKN is equal to 4x minus 3. All right, so now what we've got is a multi-step equation. If we combine like terms and solve for x, we'll get a value for x. So combine like terms, 2x plus 4, 4x is equal to 6x, so that's 6x. And then 10 minus 3 is equal to 7. So what we got then is we continue to solve this equation. We'll subtract 7 from both sides. 145 minus 7 is 138, is equal to 6x. And then finally, to get x by itself, you got to divide by 6. And 6 will go into 138. That'll go to 23 times. So x is equal to 23. But notice they didn't ask us to find x. They want us to find the angle LKM and MKN. So let's do that. First, we'll look at LKM. That's equal to 2x plus 10. So what we can do is just plug in the value for x where we see x in that little equation or that expression. So x is going to be 22 or 23. So it's going to be 2 times 23 and then plus 10. All right. So angle LKM, we can say, when we crunch that out, 2 times 23 is 46, plus 10 is 56. So here is our first angle. We can do the same thing for MKN. So angle MKN is equal to 4 times X, which in this case is 23, and then minus 3. So 4 times 23, that's going to be 46. That'll be 92 minus 3, which would be 89, correct? So angle MKN is equal to 89. All right. And once again, just like with the segment addition postulate, you can check your work by adding the angles together. 89 plus 56 should equal 145. Okay. So if you add those up, 9 and 6 is 15. Yeah, it equals 145. So we know that we've done the right thing there. All right. What I want you to do is take a second and pause the video and try this second example on your own. Okay. So I'm back. I hope you made your attempt. I hope you come up with the right answer. In this case, we've got something similar. We've got an angle being cut into two smaller angles. KLM is a straight angle, and you remember from before that a straight angle is equal to 180 degrees, right? So that's something you should know. They might not ever tell you that a straight angle equals 180. You need to know that. All right. They want us to find KLN, this angle, and then NLM, this angle. And just like before, they break it up into two things. So using the angle addition postulate, so angle KLM is equal to angle KLN plus angle NLM. And just like before, we can substitute KLM. They didn't explicitly say it was equal to 180, but by definition, a straight angle is 180. So we'll plug that in. And then KLN, they give us in the problem, is 10x minus 5. And then NLM is 4x plus 3. All right, so then you combine like terms. 180 is equal to 10x plus 4x is 14x. Negative 5 plus 3 is negative 2. And then continuing on down, we add 2 to both sides. So we get 180, or 182, is equal to 14x. All right? So then we divide both sides by 14. And what we will get, well, 14 will go into 18 once. And then we're left with 42. That'll be 13. So x will be equal to 13. All right. But again, they didn't ask us for x. They asked us for the angles. So angle KLN, that's equal to this angle up here, 10x minus 5. So 10 times 13 minus 5. So angle KLN is equal to 130 minus 5, which is 125. Then we'll do the same thing for NLM. So angle NLM, that's equal to 4x plus 3. So x here is 13 plus 3. So 4 times 13, that's 26 times 2 is 52. Plus 3 is 55. So angle NLM is equal to 55. And once again, we can check our work. 55 plus 125 adds up to 180. If you have any questions, bring them to class.